All right, welcome you guys. So this is going to be 1.5 part 2. And in this section, I'm just going to cover all the word problems. Um, you really want to embrace them. I've noticed students tend to skip the word problems and honestly, those are the most important ones because those are the ones that say, hey, I can actually use the math in my life. I mean, and that's the goal, right? Let's face it, is that we want to be able to use the math in the real world. I mean, you're not going to come across problems like this in the real world unless your job is my job, right? And it's like, solve that. It's going to be your job to get it to that point. And often I find students saying, "Oh, you're never going to use math in the real world." And it's the people who are saying that are the people that can't. They don't know how to use the math in the real world because I use it all the time. Um, so anyhow, I'm going to go nice and slowly through about, let's see how many examples we have here. Looks like we have 7 examples. Of course, I couldn't cover every single type that was in the section, but hopefully this is a good start for like how I go about doing it. And hopefully it helps you. Okay. All right. So let's go ahead and start with this example 1. So it says there are about 232,000 words in the Japanese language. This is 19% more than the number of words in the Russian language. How many words are in the Russian language? So don't feel bad if you've read this thing 5 times before you even start. Honestly, it takes everybody a little while to get their bearings, get a grip on the situation, fully understand the situation at hand. Okay. So I would definitely read it through a few times. Okay. And then the next thing I do is I don't go right away to math. I actually go to like English first. I'll go to words. So here's what I'm thinking in my mind as I read this problem, okay? So the first thing that I'm thinking is that the number of Japanese words, it says here, there is 19% more, or this is 19% more than the number of words in the Russian language. So in my mind, I'm thinking, okay, how do I find the Japanese words? Well, I'm going to take the Russian words. And the Japanese is more, right? So I'm going to have to add to the Russian words to get to the Japanese words. How much more? 19% more. So I'm going to add to the Russian words 19% of the Russian words. All right, so let me think about this. Oops, make that guy a little better. There are about 232,000 words in the Japanese language. This is 19% more than the number of Russian words. So I'm going to take the Russian words and I'm going to add 19% more of it to it. And that should get me the Japanese words. Okay, so, the things that we know, well, we know how many Japanese words there are. There's 232,000. So I'm going to substitute that in right here. Now we don't know how many Russian words there are. So I'm just going to put a big R for Russian words. I try not to use X, you guys. I try to use the more descriptive variable. I mean, you can use X, that's fine. But when I get done and I find R, I don't have to go back and think, well, what did I find? I mean, it's pretty clear the Russian words. Okay. Now we're going to add to that 19% of the Russian words. So let's make sure that we know how to take these words from English to math. Okay. This is something that's very common, 19% of. So 19% of Russian words. All right, so when you have a percent, you've got to make sure that you move the decimal place twice to turn it into, to go from a percent to a decimal. So let me move this down. Okay, we're going to move the decimal twice. Always, you guys. When converting from a percent to a decimal or a decimal to a percent, you've always got to move it twice. So here it is. So 1, 2, it's going to go right here now. So this is going to end up being 0.19. Okay. Then another important little fact to know is that of means multiply. So it's going to be 0.19 times R. So we'll just write that like this. That shows multiplication. Remember, no sign means multiply. So this is what we're going to get for right here. So I'm just going to draw a little arrow where we're going to insert this. We're going to insert this right here, right? And okay. And I'll talk more about this in a second, okay? But oops, I have a little story from when I worked at Jack in the Box. All right, 232,000. Now remember, there is a 1 in front of this R right here. So 1R plus 0.19R is going to be 1.19R. Now let's pause here for a second. Like, how is this useful in the real world? Guys, this is how you figure out tax. This will just be me being a side note here, okay? You are, and this is back when I worked it, so the prices probably aren't right. You are buying a jumbo jack from Jack in the Box. It costs 99 cents. And the tax rate in California, where you live, is 7.75%. All right, we still are 7.75%. The jumbo jack doesn't cost 99 cents anymore, but whatever. So one time I'm working at Jack in the Box, and the power on the register goes down, and they always had calculators next to the register. And so I was like, I got this, guys. I'm a math major, just I'll figure out what everything costs, right? So what I was doing in my calculator is I was going, okay, 99 cents times, and I moved the decimal place twice on the, and so it'd be here. So it's 0.0775. And I figured that out. So let me go to my calculator. I remember it being like 7 cents or 8 cents, I think. So 0.99 times 0.0775 on my calculator. It's given me, it's given me this. Oops, let me go back to black ink. 0.076. So since we're talking money, we know where to round. We got to round cents. So this 6 is going to round it up to, we're going to say 7 cents. So that would tell me, or 0.07, whatever. That tells me the tax, right, you guys? So what I had to do is I had to go, okay, well, it's 99 cents for a jumbo jack. And now I got to add the tax to it. Oops, I'm sorry. I should have rounded up. What am I talking about here, you guys? 8 cents. I said it, then I didn't write it. All right, so it's going to be 6 is going to round the 7 up to an 8. Okay, so I'm going to add that 8 cents to the 99 to give us $1.07, and that's what a jumbo jack was, after tax back then. Okay, so I'm doing this, and this guy Jose that works there is like looking over my shoulder, and he's like, "Hey, you could. There's a better way to do that." And I was like, "I'm all ears. How would you do it?" He's like, okay, if you want to figure out the tax, you could do it in 1 step instead of 2. Do you guys see how I did 2 steps? I did 0.99 times the tax rate to figure out the tax. Then I had to add the tax back to the original amount. He said, take the 0.99 and instead of multiplying it by 0.0775, multiply it by 1.0775. And that'll get you it in 1 shot. You don't have to do 2 steps. And sure enough, if we do that on the calculator, I'm getting this. And there's your, if you round up, right? 6 will round this guy up. There's your $1.07, right? Well, that's exactly what we just did. If you keep track of my math up here on the top, I'll do it in blue. I did 99 times 0.0775 plus 99, right? This right here is how I get the tax. And I added the tax back. Well, if I put like a little 1 after this guy, and you think about combining like terms, right? This 1 and this 0.0775 will make 1.0775 times the 99 cents. Okay, so that's what's going on right here. I could have gone straight to this line because of what that guy taught me at Jack in the Box, right? Don't we want, if the Japanese words are more than the Russian words, 19% more. Well, don't we want all 100% of the Russian words plus 19% more of the Russian words? Well, then that's going to be 1 plus the 0.19 for 1.19. So if you kind of know how to figure out tax, well, then that makes sense in this case why the 1 is there. So I could have totally skipped this step and been like, well, I want 100% of the Russian words, plus I want 0.19 more of the Russian words. Anyhow, that's just a little side thing. I mean, what's important is, hey guys, if you want to figure out what you're going to pay at the register, knowing that you just have to slide this 1 in front of the tax rate and multiply it, that'll get you the final answer. How easy is that? I know there's apps nowadays. People are like, I don't have to know this stuff, Mecklenburg. There's an app for that, right? Somebody's got to program these apps. Somebody's got to have a deep understanding of what's going on. All right. So I'm going to divide by 1.19 here and pull out the good old calculator. Maybe I'll just pull it up here, my emulator. Okay, so let's put this guy over here. I don't know why I wasn't using it earlier, you guys. All right, 2, 3, 2. So 232,000 divided by 1.19. Before I hit equals, you better tell me, am I expecting a bigger number or a smaller number? I'm finding the Russian, right? The Russian words, are they more than the Japanese words or are they less than the Japanese words? I'm expecting a number less because aren't the Japanese words 19% more than the Russian words? So the Russian words better be less than 232,000. Cool. I think we did get something less. Oops. Sorry, let me put back up my emulator. We got 194,957. 194,957.98. Now I'm just going to consult the book to see what it wants to do with the rounding situation. They just rounded it up to, oh, they just said there are about. Let me just check and see. Yeah, they have the same math and they just rounded it up to 195. Well, that's a big round. And they didn't state in the directions where to round. Man, I hate when they do stuff like that, you guys. But so if you have a test from me, my test is going to be explicit. It's going to be like round to the nearest whole number or something like that. Okay. So, I mean, answers that would be acceptable if they aren't stating. I'd probably just say round up to the nearest whole number. Because this is all just approximately anyways. Did you guys see this? There are about. So that's not even accurate, the 232. So we don't need like precision on our accuracy here. All right, there are about 194,958 words in the Russian language. Yeah. Okay, so we read it like 5 times, however many times it takes for you to digest it. We went with English first. Like, okay, well, the Japanese words, it's going to be the Russian words plus some. It's going to be the Russian words plus 19% of the Russian words. Then after we got English, we turned it into math, right? By plugging in what we know. Do we know the Japanese words? Yet. Do we know the Russian words? Nope. Okay, variable. All right, and then we chose a good variable. Hey, R for Russian words. Okay, and then we just solved the equation. Let's do it again. This one's very similar, this example too. All right, in 2014, there were 151,282 convenience stores in the United States. The total number of convenience stores in Texas and in California was 26,379. There were 4,003 more convenience stores in Texas than in California. Find the number of convenience stores in Texas and in California. So again, I'm going to go to words first, okay? Okay, let me write down anything that I know. Okay. First of all, they gave us a bunch of numbers we're not going to use, and that works. That throws people off, man. It really works. And that's why they put them there, right? Be like, hey, I'm going to throw these extra words, these extra numbers in here. Let's see if you can figure out which numbers are the numbers we're going to need. Okay. All right, I'm looking at this this sentence right here. The total number of convenience stores in Texas and in California was 26,379. I can make an equation out of that. So in my mind, I'm thinking, here's what I'm thinking in my mind. The stores in Texas, so stores in Texas, let me put this in parentheses. Plus the stores in California equals 26,379. Whoa, that was weird looking. 379. Okay. That's the only thing that really stands out to me that I'm like, well, I think I could write an equation off of that because, the total number of convenience stores in Texas and in California was this. Okay, then the Texas ones plus the California ones has to equal that. I don't think this one was that hard for you guys to pick that up. Now, the next thing that's going to make this kind of hard, I'm going to go ahead and use T for the Texas stores, plus I'm going to use C for the California stores. Now, here's the problem. This is too many unknowns, too many variables. Too many variables. In one equation, if you only have one equation, you're only allowed one variable. If you have two equations, then you're allowed two variables. If you have three equations, then you're allowed three variables, etc. So, oops, this right here is too many variables. So we have to get this down to one variable. Well, let's keep reading. There were 4,003 more convenience stores in Texas than in California. So here's what I'm thinking. The stores in Texas has to be the stores in California plus, it says there's 4,003 more in Texas, so plus 4,003. That shows Texas having more, right? You're going to say, okay, how many are in California? I'm going to add 4,003 to that, and that should get me how many are in Texas, okay? All right, so this is T. Stores in California is C. So check this out. We know what T is now in terms of C. So we can take this and substitute it in right here. You know what? Let me rewrite that so it's not on top of the other stuff. There we go. All right, so instead of T, you guys, we're going to put C plus 4,003 because it says T equals that. So instead of T, we're going to put C plus 4,003 in for the T. But then we still have this C. I'm going to pause, just make sure everybody's with me. Okay. All right, so we know that together Texas and California make 26,379, but we can't have two variables. So we went over here and we said, well, the number of stores in Texas, that's the same as the number of stores in California plus 4,003. So instead of writing Texas, we're just going to put California plus 4,003 in for the T, and don't mess with anything else in the equation. Bring everything else down. And now we're golden, you guys. We've been solving linear equations in the last video. We got this. Combine like terms. So C plus C is going to get us 2C. Remember, the number in front of the variable is last, so that 2 is going to be the last thing I do. I'm going to do the 4,003 first. So I'm taking away 4,003 since it was addition. We always do opposites. All right, let me pull up the calculator here. So we've got 2, 6, 3, 7, 9. Take away 4,003. 2, 2, 3, 7, 6. And now we're going to go ahead and divide by 2. All right. So let's pull back up that answer and we'll just divide it by 2. 11188. 11188. Again, there's no reference to where they want us to. Oh, it went in evenly. I guess we don't have to round, huh? All right. Now, what did we find? This is why having your variables, nice variables instead of X and Y. It's like, dude, I know what I found. It's a C. That's the stores in California, right? So now let's go in and get the stores in Texas. I'm going to box this guy as the stores in California. But then we have to go and substitute that in right here to find out how many stores there were in Texas. So stores in Texas is going to be 11,188 plus 4,003. So the number of stores in Texas plus 4,003. 15191. 15191. There we go. All right. So starting off with English, working our way into math and knowing the fact that if there's 2 variables, I have to have 2 equations. So since I only had 1 equation, I'm only allowed 1 variable. There's got to be something that allows me to take it from 2 down to 1. And that's where this came into play. Okay. Now I'll ask students if they know the distance formula. There's actually 2 distance formulas. And most of the time they don't know this. So let's just go over it and help you to understand you actually do know it. When I was in school, my teacher said dirt. I'm going to show you what they meant by that. All right. So dirt, here's your D-I-R-T, right? Dirt. Let me highlight the fronts. D-I-R-T, if you remember dirt. Oops, I can spell. Distance is rate times time. So that's what this is saying right here, you guys. Distance is rate times time. Now let's make sense out of this. So I don't want you to memorize stuff. I want you to make sense of stuff and understand it. Now, I'm going to propose a little question to you that I think you can answer. And I want you to understand, oh my gosh, you did know this formula. You just didn't know you knew it. All right, if you drove 60 miles per hour for 2 hours, whoa, what distance did you travel? And I don't want you to use this formula. I just want you to think. Don't use this formula because you can answer this. You drove 60 miles per hour for 2 hours. Okay. Well, let's make this the hours and let's make this the distance. In the first hour, you drove 60. So in the second hour, you drove 60 plus another 60, right? So that's going to give you 120. So you drove 120 miles then, right? 60 the first hour, 60 the second hour, because you're doing 60 miles per hour. There's your 120. And you could just, find anywhere down the road. Like, let's say you wanted to know, okay, if I traveled 4 hours, well, according to this formula, distance equals rate times time. You would take the 60 miles per hour, you multiply it by 4, and you get that you traveled 240 miles. Let's see if that makes sense. Take the 120, add another 60 to it. That's 180. Take the 180, add another 60 to it. Bam, 240. This is working. Okay. So distance equals rate times time. Dirt. Distance is rate times time. So example 3. And guys, I don't have enough knowledge of airplanes. I'm probably going to read this stuff wrong and butcher it, but my math will be right. So forgive me on not knowing the airplanes and how to read their names and stuff. All right, it says Delta Airlines fleet includes B737/800s, each with a cruising speed of 517 miles per hour, and Saab 340Bs, each with a cruising speed of 290 miles per hour. Suppose that a Saab 340B takes off and travels at its cruising speed. 1 hour later, a B737-800 takes off and follows the same route, traveling at its cruising speed. How long will it take the B737/800 to overtake the Saab 340B? So this is things that I'm looking at. How long? So I don't know the time, right? How long means I don't know the time. Find the time. And to overtake, let's just digest that, okay? Let me see if I can write on here with 2 fingers at once. I can. Okay, cool. All right, so we're going to make this first one the B737/800. And then we're going to make this last one the Saab 340B. Now, what happened was the Saab takes off first. That's what it says. Suppose that a Saab takes off and travels its cruising speed. An hour later, the other one takes off. So the Saab's going to, here they are, the Saab's going to take off. It gets a head start. But then the other one, finally overtakes it. Now, where is it going to overtake it? Right here when their distances are exactly the same. Let's pretend they're the same. My drawing isn't very good. After that, the B737/800 is going to overtake it, right? It's going to be going faster from then on, okay? Okay. So the key thing is when one plane overtakes another plane, it's going to be at the point where they've traveled the same distances. So let me just show you that again, right? The Saab takes off first, right? And then the 737/800 is, and right now where they're equal, this one up here is going to overtake the other one. So the key thing that we need to remember is their distances are equal. That is the very first thing I'm going to write down, okay? All right, so let me write that down. The distance of the B737/800 has to equal the distance of the Saab. I cannot write Saab, you guys. There we go. Saab 340B. So make sure you understand that. Like when one plane finally passes up, overtake means passes, right? It's going to pass it once their distances are equal. That's why we set the distances equal. And now distance, well, we know what distance is. Distance is rate times time from that last slide. So what we're going to need is we're going to need to replace the distances with rate times time. So we're going to need the rate of the B737/800. We're going to need the time. All right, over here, same thing. What are we going to replace the distance with? We're going to replace the distances with rate times time. So we're going to need another rate times time. But this time, the rate of the Saab. Okay, so to recap, we know their distances equaled each other because they will have traveled the same distance when the one plane overtakes the other. Nowhere up here does it give us the distance. So we have to change the distance into rate times time using this formula right here, DIRT, distance is rate times time. All right, let's start filling in things we know, you guys. Do we know the rate of the B737/800? Yeah, it says right here it has a cruising speed of, oh gosh, I can't write a straight line. The cruising speed of 290. Do we know how long it took? Nah. How long means we don't know. It says find the time. So I'm just going to go ahead and leave the time as time, okay, or an X or whatever, okay? All right. Do we know the rate of the Saab Oh, guys, sorry, I did not read properly. Rewind. I can read. So the the B737/800, its speed was 517. Sorry about that. It's the Saab that does a cruising speed of 290. Now, I don't know this guy's time also, but I can't be going and putting an X here. So let's think about this, right? Who had, it says right here, what? 1 hour later. Okay, so let me read this again. Suppose that a Saab takes off and travels its cruising speed. So the Saab took off first. An hour later, the B737 takes off. Okay, so the question is, who had more time? Well, the Saab had more time because it took off first. How much more time? An hour more, right? So instead of putting X, I'm going to put X plus 1 for its time. So the Saab took off first. That means it got an extra hour that the B737 didn't get. So instead of taking X, which is the B737's time, we're going to do X plus 1. Now, by the way, another way you could have written this is you could have put the X here and said the Saab took X. Then that means that the B737 took X minus 1. Okay, so it doesn't really matter. You can almost just fix it. Put an X somewhere and then make sure you understand if you need to be adding time or subtracting time. Okay, so the Saab had 1 hour longer because it started an hour before the other one. So that is why we put an X plus 1 for its time. All right. Just pause a second to digest, right? Because guess what? From here, smooth sailing. The hardest part's done. All right, so hopefully that setup makes sense to you. The number in front of the variable is last. So we're going to move this to 90 first. Oh, hold on. Sorry, there's variables on both sides, guys. Sometimes I don't see stuff. So if there's variables on both sides, we said move the smallest. So we're going to move the 290x. And so that's going to get us 227x. Okay. And then we're going to go ahead and divide by 227. So we find out what x equals. Okay. So 290 divided by 227. That's not helpful. So bam. 1.277. So if I don't say where to round it, there's going to be a house rule in my class to round to the third decimal digit. I'm just used to that from teaching AP. So because it's 2775, the 5 is going to round the 7 up to an 8. Okay. And this would be hours. All right, now let's kind of make sure we know who that was. Was that for the Saab or was that for the B 737? Well, if you trace it back, right? X, the first, oops, that X is right here, right? And that's going to be for the B737/800. So I'm going to go ahead and say for B737/800, we'll box that. Now remember the Saab got an hour more, right? So you can go and you can plug in the 1.278 right here, and that'll help you find the Saab's time. So add 1 to it. So 2.278 hours for the Saab. Bam. Okay. Now, I know these are long, and the first few times that you do word problems, they are long, but then they start to seem algorithmic and you get them instantly. I promise you guys. I just spend a lot of time alone thinking about stuff. And then once you understand it, it's easier and easier to get the next ones. Okay. All right. Headwind, tailwind, with the current, against the current. Okay. An airplane that can travel 375 miles per hour in still air is flying with a 25 mile per hour tailwind. How long will it take the plane to travel 700 miles with the wind? Now you can see that we have a rate here, right? Miles per hour, that's a rate. Miles per hour, that's a rate. Miles, that's a distance. So that's going to make you think, I might be using dirt. Distance is rate times time, right? I'm going to write them down, being hopeful. And I'm going to ask myself, do I know any of these things? Yeah, I know the distance. The distance is going to be 700 miles. Now, the hardest part to this problem is the rate. Okay. We are flying with the wind. So that means the wind's going to make us go faster. So the plane in still air would have gone 375, right? But that's not actually how fast the plane is going to go because it's getting this little boost, right? It's got this tailwind that's going to speed it up and make it go faster. So for the rate for the airplane, it's going to be 375, the speed that the motor's trying to make it go, but it's going to get a plus 25 from the wind. Now, how long? We don't know time, right? That's what we're trying to find is how long. So t is just going to stay t. All right, so we can solve this. There's only one variable, you guys. We got this. So 375 plus 25 is a nice even 400. We'll divide by 400 to get the t by itself. And that would get you 7 over 4 if you use the cross off the zeros trick, right? Bam, bam. So this is going to be, probably would want that as either a mixed, we're talking hours because of miles per hour, right? Or you could put 1.75 hours, whatever. 1 3/4 of an hour. Either one of these is acceptable. So the key parts to this, recognizing that you have to pull this D equals RT out. It's not like it said use D equals RT. You had to figure out that you need to use this formula. The next thing, understanding that if you're with the wind, it's going to be a plus. With the wind, it's going to be a plus. Example 5, a kayak moves at a rate of 12 miles per hour in still water. If the river's current flows at a rate of 4 miles per hour, how long does it take the boat to travel upstream? Okay, so I'm getting the sense of D equals RT again, because they're giving me distance, they're giving me rates, okay? I'm going to write that down. Now, do I know the distance? Yeah, it says the boat travels 36 miles. So I'm going to put a 36 in for the D. Now, the rate on this one, if you're going upstream, you're going to get slowed down. If you're going downstream, then the water's current is going to help you go faster. But if you're going upstream, you're fighting the current, right? So the kayak is going 12 miles per hour in still water. It's trying to go 12. But this time we're going to subtract away the current, the 4 mile per hour current, because we're going upstream, right? So that's actually going to be subtraction, not addition. Change that to downstream and it would be plus. We'd be going faster. All right, and then we'll substitute in the time. So we get 36 equals 8t. Let's divide by 8 to just get a 1t. Now 36 divided by 8. This, if you put that in, 36 divided by 8, 9 over 2 is totally not satisfying. So you can hit the S to D button, 4.5. 4.5, we're dealing with hours again, you guys, miles per hour, everything's in hours. So 4.5 hours. Okay, so we had an example of when we would add and when we would subtract, right? We got this headwind, tailwind, upstream, downstream. Okay. Interest. Now we're going to talk about interest a lot in this class, okay? We're not going to talk about simple interest that often, but you got to know what all these interests mean. So what I'm going to do is I'm going to make a table to help us understand what simple interest is before we go into the formula, okay? So I'm going to make this the year. I'm going to make this the interest. Okay, I'm going to make this the amount, the total amount. Okay. I'm going to give you guys a scenario, okay? So I want you to be able to understand what simple interest is. So here's the scenario. You invest, let's say you borrow. You borrow $100. Let's keep it simple. With 20% interest. Ooh. Okay. 20% simple interest. That's our scenario. So what that means, tables help me digest stuff. So let's start off with the table. So year one, you haven't been charged any interest, or year zero, you haven't been charged any interest. The total amount that you borrowed is 100. All right. Now, if you're going to get 20%, well, 20% of 100, we just got done saying that for percent, you got to move the decimal twice. So it's going to be 0.20. We just got done saying that of means multiply, right? So we're going to multiply by 100. That's going to give you 20. And maybe you just logically could tell that 20% of 100 is 20. Okay. All right, so that means we're going to get $20 in interest. So the total amount we owe now, or we borrowed now, or owe, is 120. Now, the way that simple interest works is they're always going to give you interest just off the original amount borrowed. They're not going to give you interest on your interest. So no matter what, it's going to be like 20, 20. You're just always going to keep adding 20. So this would be 140 then if we added 20 more dollars in interest. This would be 160 if we added 20 more dollars. This would be 180, etc. Now you could use the formula to find this, right? So for example, if we use I equals PRT, and let's find it for year 4. Okay, so the interest, well, the principal P, the original amount borrowed, is 100. The rate is 20%, but you can't put percents into the math problem, so you got to put 0.20. And the time is 4. So we got 100 times 0.20 times 4. 100 times 0.20 times 4. So we have $80 in interest, you guys. So what we're going to do to find the amount is we're going to take the fact that we borrowed 100 and we got $80 in interest. So that tells us we have 180. And what do you know? It matched for year 4. Okay. So the main takeaway, simple interest means that you're only going to get interest on the original amount. They are not going to give you interest on the interest. Okay. We'll learn about that later. That's called compound interest. Okay. Simple interest is actually very hard to find. Of course, your credit card companies want to add back in the interest and now charge you interest on the interest, right? Of course they want to. It gives them more money. So simple interest is very hard to find, but here it is. Okay. So the formula I equals PRT. This P principal, that just means the original amount borrowed or the original amount received. The original amount loaned or borrowed. All right. The Marian's 2 student loans total $28,000. One loan is at a 5% simple interest and the other is at a 3% simple interest. After 1 year, Demarian owns $1,040 in interest. What is the amount of each loan? Okay. So English-wise, here's what I'm thinking. First thing that comes to mind. I know that I can find the total interest by adding together let's see, the interest from the 5% loan. Plus the interest from 3% loan. So let me just make sure that makes sense. The total interest is going to be the interest from one loan plus the interest from the other loan. Yeah, that makes complete sense. Okay, now I'm going to start filling in things that I know. Do I know the total interest? I do. It says right here, Demarion owes 1,040 in interest. So I'm going to put that here. Now, do I know the interest from the 5% loan? I don't. I do not know the interest from the 5% loan, okay? But I have a formula for interest. It does say simple for both, okay? So we're going to be using this guy twice. We're going to use them once for, so PRT. Oh, I thought it changed the color. So we're going to do PRT, and I'm going to subscript them from the first loan. And then we are going to do PRT for the second loan. So P2, R2. Okay. All right. So let's think about the things that we know. Do we know the principal for the first loan? We don't know how much he borrowed from the 5% loan. They just gave us the total. It's like, hey, he borrowed 28,000 total. I don't know if he borrowed 14,000 from each. I don't know if he borrowed 10,000 from one and 18,000 from the other. Like, I don't know how this was divvied up. So I'm just going to put an X for right now for the principal. I do know the rate was 5%, right? So we always have to move the decimal twice. So into the problem is going to be 0.05. And I do know the time. It says after 1 year. All right, so we were given 1 year. Let's do the same thing over here. We know that the rate is 3%. So we're going to move the decimal twice and make that guy a 0.03. And it was still 1 year. Now, what's tricky is I can't put another variable like a y here and be like, I don't know that one, so I'll use a y. Because remember, if you only have one equation, you're only allowed one variable. So here is what I am thinking. Off to the side, I'm going to do a little bit. Oops, little example here. Wow, it got worse. There we go. Okay, perfect. I'm going to call this loan 1, and I'm going to call this loan 2. All right, so let's say that he borrowed 10,000 from loan 1. How can we figure out how much he borrowed from loan 2? A lot of people would just instantly say 18,000. So to get that, technically what we did is we did 28,000 minus the 10,000 to give us 18,000. If we said that he borrowed, I don't know, 8,000 from the first loan, then 28,000 minus 8,000 says that he borrowed 20,000 from the second loan. I'm going to go abstract with it now. If he borrowed X from loan 1, which he did, right? Then to find the other one, we would just do 28,000 take away X. So that's what's going to go in here. 28,000 take away X. That way we keep it one variable. That's our sneaky way of making sure that we only have an X. Okay, multiplying by 1 isn't going to do anything. So we can pretty much ignore these and be like, well, they're not going to do anything, right? All right, so here's the equation that we have. The hard part is done, you guys. We got 0.05 times X, because multiplying by 1 doesn't do anything. And then we have, I'm not going to worry about this guy because it's a 1. I'm going to distribute the 0.03n. So 0.03 times 28,000. 0.03 times 28123. I'm getting 840. And then 0.03 times X is just 0.03x. And we'll combine like terms. So the like terms here being the 0.05x minus 0.03x to give us 0.02x. All right, now the 0.02 is in front of the variable, so that's last. So let's get rid of the 840. So this should be 200. Divide by 0.02. You go to your calculator and you punch in 200 divided by 0.02. Get 10,000. So 10,000, that's how much he borrowed from the 5% loan. So let's put from 5% loan. All right, now to figure out the other one, well, we already did the math, it looks like, right? I mean, we did it right here. But yeah, so 28,000 minus 10,000 means that we have 18,000. Okay, so basically you're just taking this X and you're substituting it in right here to find out the principal from the second loan. All right, so let's just write that down. 18,000 from the 3% loan. And they better add up to 28,000, you guys, because that's how much you borrowed total. And they do add up to 28,000. Awesome. All right. Getting brain drained because these are all word problems. Luckily, this is our last one. Okay. All right. Example 7. In December 2009, a solar energy farm was completed at the Denver International Airport. More than 9,200 rectangular solar panels were installed. A solar panel or photovoltaic panel converts sunlight into electricity. The length of a panel is 13.6 inches less than twice the width. And the perimeter is 207. Find the length and the width of a panel. Okay, so make sure that you don't memorize the perimeter formula, but that you like understand where it comes from. So if you have a rectangle, this is going to be L and this is going to be L for length. This is going to be W and this is going to be W. The perimeter means the distance around. That's what it means. Just remember that and you'll be able to always find the perimeter. Perimeter is the distance around. All right, so if we wanted to find the distance around and we were walking around this rectangle, we'd have to walk W plus, then we'd have to walk L plus another W plus, and then we'd have to walk L, right? And so if you combine like terms, you're going to have 2 L's and you're going to have 2 W's. So that's your perimeter formula for a rectangle, at least. You could have the perimeter around many different objects, but that's going to be the one for a rectangle. Okay. All right. So when we look at this, the meaty part of this word problem is right here. The length of a panel is 13.6 inches less than twice the width. Okay. So the length is less than is going to mean that we're going to have to subtract. Now I claim twice the width. That would mean twice the width is 2 times the width. And less than would mean take 13.6 away from it. Now what I want you guys to notice is anytime we see the words less than, not is less than, but less than, you're going to switch the order on the words. A lot of people would put, okay, 13.6, less than means minus, and then twice the width. And they'd write it wrong. Let me make sure that it's clear. Why do we switch the order on when we see less than? Okay. I think it goes on the outside on you guys. I just never liked that. Oops. Is that right? You guys can probably tell me. All right. I'll give you a really simple example and you'll be like, oh, okay. All right. What number, don't think too hard. What number is 2 less than 5? If I said, what number is 2 less than 5? I'm sure most people would say 3, right? Okay, so did we straight up go 2 minus 5? No, we did not. That would be -3, right? We actually took the two numbers and switched the order and said 5 minus 2. That's the one that gets us 3. Okay. So anytime you see the words less than, make sure you switch the order. So I did the twice the width first over here, and then I did minus the 13.6. Okay, we're ready to go. Let's write down this formula and let's start plugging stuff in, you guys. Let's start substituting in what we know. So do we know the perimeter? We do. It straight up says the perimeter is 207. 207. Do we know the length? Yeah, we just wrote an equation for the length, right? That's this guy. So we're going to put 2w minus 13.6 in. Do we know the width? No, but that's okay. I'm allowed one variable, so I'm allowed the w. Done with the hardest part. Let's distribute. So 4w. 13.6 times 2 is 27.2. Find like terms. 2w plus 4w gives us 6w. All right, save the 6 for last. It's in front of the variable. So 27.2's got to go. I'm going to add a 0.0 on this guy. So we got 2, 14, carry the 1, 3. There it is. And then divide by 6. Okay, so 234.2. 234.2 divided by 6. 234.2 divided by 6 equals STE. So the width is, let's just round it, you guys. So the width is 39.03. This is inches. All right, we got the width. Now to find the length, all we got to do is take that guy, plug him in right there. L equals 2 times 39.03 minus 13.6. Okay, so if we double this, gosh, 39 double. Let's see, 40 plus 40 is 80, 2 less than that. 78.06. Okay, 78.06. 8.06 minus 13.6. Hmm. 70. Okay, so 64.06. Is that what I have? Sorry, I forgot. 46. Just kidding. All right. And this is inches also. It didn't say word around, and it will in either a textbook or on Connect Math or My Math Lab, whatever you're using in your class. It'll be specific and it'll say around here. You won't be guessing like this. Okay. All right, cool. So length times 2 plus width times 2 is the perimeter of a rectangle. We derived it over here. Okay. We learned that less than is subtraction, but you got to switch the order. I think that was the key thing on this problem. All right, you guys. Hopefully you feel slightly better about word problems. And I tried to pick problems for the homework that kind of match these a little bit, so I wasn't just pulling stuff out of thin air. So hopefully this helps. All right, you guys. Thanks for joining me. Take care.